All right, we're ready to get started. Here we are. Where are we? We're finishing up chapter 9 today, right, Jonathan? We're finishing up chapter 9. Next week's chapter 11. Our quiz then will be right after that. Where do we want to start today? We're supposed to have a guest, and our guest is not here. That's bad news, but here we go. You ready? Let's start. No. Let's start by refreshing a forward and backwards pass. Look at your little notes that you took for the rules on a forward pass, the rules on a backwards pass. We had some active people who need to see this. Here's the key. Top left-hand corner would be earliest start. Top right-hand corner is earliest finish. I got something for you, Jeff. Bottom left then is latest start. Bottom right is latest finish. Okay, there's our number. There's our key. Here's the start. We got A and B coming right out of the start off the bat. So their earliest start would be what number? 0. Thank you. A is 6 units of time, so earliest finish would be 6. Let's go to B, earliest start. 0, 4 units of time, their earliest finish. There we go. D is preceded by A. So its earliest start will be after A finishes, which is when? 6, add 5, 11. E, earliest start. 6, earliest finish. Very good. C, 6, finish. 9, add 3. Where are we here? A, B, C, D, E, F. F, look at it carefully. Hang on. Hang on. Jason feels very confident about this. Hang on, let me look. I don't even know the answers. Okay, we got 2 possibilities coming out of 2 of them. So it's either a 9 or a 4, and you're supposed to go with which number? The smallest or largest? So that's right, forward pass, use the largest, 9 plus 4. You know, you guys, you're speaking up like you know this. But when it comes to the quiz, what's going to happen? That's what I want to know. This is it. I mean, if you're feeling it, you got to feel it all the way through to the quiz. You got to find it.
Never pass up an opportunity to disappoint your professors.
Please pass up that opportunity. Please pass up that opportunity to disappoint me. G, two activities preceding it. Very good. Add 2. 11. H.
11.
No. 13. No, we're on H. Earliest start. No. 13. Was that a 13? Yeah. I thought it was a 3. Thank you. 13. Add 6. Thank you. I. Hang on, I gotta look at the 2. Very good. Could have been though. 7's the alternative, but it's a 13. Add 6. 19. H-I-J. Up here, J. Either a what or a what? If you're choosing the 19, add 3. 22. K. Hang on, we either have a what or a what? 11, you're going with the 19, add 5. 24. Is that it? This project is expected to take how many units of time? Hey, did we do something wrong? Somebody better check this. I thought it was supposed to be 23. Let's keep going. I'm shocked. No, maybe it's supposed to be 24. Okay, backwards pass. You ready? Let's go with where we left off. K. H-I-J-K. K then, the bottom right's going to be what? The latest finish. The whole project time. Minus 5 is 19. We just discovered what? Critical activity. Go to J, bottom right-hand corner, latest finish. The whole project time, because it's coming out of the finish. Minus 3. 21. Is this a critical path? No. So it must have slack. Slack of how much? 3 or 2? 2. All right. Let's go with I. I has just K after it, so latest finish would be 19. Subtract 6 is 13. Slack would be 0 because it's a circle it. H. H only has J after it, so its latest finish could be 21 minus 6. 15, thank you. Critical path, or critical activity, no, so it has slack of 2. 2, very good. The difference from either the finishes or the differences between the starts, for those that were absent. Huh?
It is 23.
Wait, where was our mistake?
I just went through and did it. So for, I think,
Activity,
okay, so when I got to K,
K.
I got 18 for the first.
K had either I at 19 or G at 11.
Yeah, but 13 was, oh, never mind, that is 19. Never mind.
Okay. So we're still at 24?
Yeah, you are.
You gave me hope. F. Oh no, I'm sorry, G. G has only one activity after it, so its latest finish could be 19, subtract 2, 17, critical path, yes or no? No, so it has slack of 8. F, now here we go. 2 activities after. It proceeds 2 different activities. Our choices are between what 2 numbers? 15 and 13, and when we're going backwards, we pick which one of the 2? Smallest, there you go, which is, what was I on? Thank you. Minus 4 is 9, slack or critical? There we go. E. E has both H and I after it, so what are the 2 numbers we're looking at? 15 and 13, so we use 13 minus 1, 12, slack. How much? Thank you. That was E. D, we only have 1 activity after it, so we use which number? 21 minus 5. 16, slack. 10, that's a big slack. C has 2 activities. What are the 2 numbers we're looking at? 17 and 9, we're going to use which one? 9 minus 3 is 6, slack. B, 2 activities. What are the 2 numbers we're looking at? 17 and 9, we're going to use which one? 9 minus 4 is 5, slack. 5. Either the difference between 9 and 4 or 0 and 5. They're both 5. And then A has 3 activities after it. What are the 3 numbers? 16, 12, and 6. And we're choosing the smallest, which is 6. Subtract 6 and 0. What we just identified. Our critical path, help me out. A, C, F, I, K. Very good. That's our review. That's our review. I think you got it.
So, okay, so the top is the largest, the bottom is the smallest one.
No, when you're going forward, you got to make a decision. You always pick the largest of the choices.
And then when you're going
Back, you always pick the smallest of your choices. That's how I would write that down to refresh when you're doing forward and backwards pass.
Is this one out of the PowerPoint?
It is, but don't tell anybody that.
Because I found out where the mistake was.
It is 23 then?
Yeah.
Oh.
J is supposed to be 20.
Which one's that? Right here?
Yeah, and then H is 14.
Okay, let me figure this out. So 13
Yep.
plus 6 is 19.
Yep.
19 plus 3,
Yeah, that's right. The bottom.
22. Okay, stop there.
Okay.
Okay, now, so that means if this were the end, that would be 22, but we got to follow this one. This is where the mistake would be if it's supposed to be
Yeah,
23.
yeah.
So here we go. We came from this 19. Is that wrong?
Yeah.
That's wrong.
Yep.
So that 13's wrong.
Yeah.
So that 13 came from, hang on, here. So that's wrong.
No,
9
that's
plus
right.
4 is 13.
Because you have 6 instead of 5, and the PowerPoint is 5.
That's a 5?
Yeah.
Oh, there it is. We got to figure this out. Does that change everything?
Yeah. Well, just the last 2.
Right. Okay. We'll look at this again in a second. But first, I want to know what that 12.7 is. It's a number. It's a number. No. What'd you say?
Sometimes it's not lights.
Anyway, the time for stop this?
Yeah, like between so you know.
Oh, yeah. That 12.7 used to be a record of how much debt consumers in America have. 12.7 trillion. That was a record in 2008, just before the crash. And now we just surpassed that record. Currently, it's 13.34 trillion in consumer debt, passing the record that took place just before the 2008 crash. Everybody understand that?
Yeah.
That's how you want to look at it. All these things I'm pointing out, such as, hey, what's going on? Remember this one before? The short-term amount of interest you should be getting when you invest in the United States of America through their treasury bills should be lower the shorter amount of time that you're committing your money. If you go all the way to 30 years, this should be the highest rate. Notice, look what's happening right here. These are lower than these, which is unheard of. That's called inverted. Again, an economic signal that something's happening. An economic signal that something's happening. Do you know what that 1.56 is? That's also a brand new record of student loan debt ever in history. 1.56 trillion dollars in student loan debt. The reason that's important is there's a lot of friends of mine who learned a very important lesson about student loan debt. No matter what happens in life, and you end up saying, oh, I'll just claim bankruptcy, student loan debt never leaves. Never. No matter if you go bankruptcy, you go Chapter 11, Chapter 9, student loan debt's with you forever. It cannot be erased. Even when you die, your estate still has to pay the student loan debt. If there's a plus in the estate. Absolutely. That's one thing. A lot of people think, oh man, I'm having troubles, I'll just wipe out all my debt. That stays. I had a friend who did this after college, wiped out all of his debt. About 10, 15 years later, got married, had children. We're going to buy a house. Could not get a home loan because they went default on a student loan. They had to pay the full student loan off in full to get approved for anyone would give them a home loan, and they were living in California at the time. So the lesson is, take your student loan debt seriously. It never leaves you, no matter what you think is going to happen in the future. That will always be with you until it's paid off. Or if you find a way to, you could go and work in a deprived area or something like that, and possibly get part of it erased. You got to work as a teacher maybe in a city school. There's all these little things you could possibly get some of it erased. But basically, plan on paying that. Now, I don't know how low interest rates are on student loans anymore, but there used to be some of the lowest interest rates. Like mine was 3%. Are they still pretty low? Yeah. They are? You don't want to be in a hurry to pay it off if it's low. Because you realize all of you are about to get to the job market, which you will be making more money you ever made in your whole life. Do you realize that? Yeah. You do? I mean, it did take, I was 3-4 months out of college, I went from making $4.25 an hour, 20 hours a week, to $22,000 a year. Yeah, I remember this back in 1980, a lot of money back then for me. More money I ever made my whole life. And I realized I spend less than what I make. I can take the difference and invest it. And all of a sudden, I saved enough money. My goal was I want to save enough money to pay my student loan off. That was like my biggest payment. I want to pay that student loan off. And it took a while, but I finally go, wait a minute. Why do I want to pay that student loan off at 3%? The money I'm saving is earning 7%. Maverick, I want to delay the student loan. I have enough now to pay it off, but I'm making more than what I would save by paying it off. That's when I realized, hey, can I delay this? Sure, we can give you 6 months, just pay on the interest, and that will extend your loan 6 months. That's 6 more months I get to make money on their money, called leverage. Companies do it every day. Be somebody who understands leverage. Take advantage of low-cost debt, make money on the debt. And that's how you should treat your student loans for that low interest rate. Because when interest rates start going up again, you will easily, in very safe investments, be able to beat the rate. And when you save enough to pay it off, decide whether you're better off just making the regular payment and keeping the money invested, making money on their money is what it's like. All right. Now, where are we going here? You ready? We're going right here where we left off. I told you in most, when you're building a building, it's very easy to know exactly how much time it's going to take for the activities, but many activities are not building a building. And so you don't know for sure how long the activities are going to take. So you try to get a range of activities. You always have someone at the table who says, oh, no way is it going to get done in 4 hours. It's going to take 8 hours. And everybody debates, and then you go, well, we all agree it would be right around 6 hours. So that would be the most likely. Somebody swears they can get it done in 4. And somebody says, no way, if things don't work out right, it's going to take 8. Pessimistic, optimistic, most likely. And I said in Tuesday's lecture, you need to convert, once you get all your activities and their times, which is the hardest part of all this, is getting this together. The rest of it's just not that bad. It's this in real life that takes time. You're going to be meeting out. Please, whatever company you're at, encourage them to use video conferencing so you're not having to waste a whole bunch of time going to meetings and going to another meeting. And in my case, we had different locations you had to drive. What a waste of time it was. Let's calculate one of these. Pick an activity other than A or B or other than C, pick any of them. H, let's go with H. The formula, back a few slides, says you take the most likely amount of, H is too easy. Darn it, but let's do it. You take the most likely time, which in this case is a 6, and multiply it times 4. So in this case, that'd be 24. It's putting 4 times the weight on the most likely time compared to the other 2 times, the longer and shortest time. We're then going to take 4 of those and add the longer time, which is a 7, and the shorter time, which is a 5. So we got 29, 36. 36. Then you divide by, we used 4, 5, 6 numbers, you divide by 6. Our weighted average, that's what we're doing, because we're putting all a bunch of weight on the most likely. The reason this turned out to exactly 6 is because these are exactly 1 apart. Had we picked a number, look at this, is 4.5 apart compared to a half, this would not turn out to be 1.5. This put a lot of emphasis there, so it'll be closer to 1.5 than 5. But, so anyway, this is 6. You have to do this for each of these activities, and when you do that, now you treat it just like we did the forward and backwards pass with known activities, which is right here. Now, there's my mistake, because what we just did is this. Your review is because even if you're taking activities that don't have true activity time, they're uncertain, once you do the math on it to turn it into an activity time, you treat it just like known activity times. So this whole thing, this was my mistake, right?
Yeah.
This whole thing is going to be 23 units of time. Is that correct? That's the expected time. All right. Are we recording this? Because I know some of you hated stats. Is that true?
Yeah.
Yeah.
100%.
That's the loudest I've ever answered a question. I just want to tell you. I don't know what that means a lot of times. But, here we go. I'm about, if you're willing to just really focus on this, I'm going to bring stats down to a level that I hope everybody's going to get. Are you ready? I hated stats at one time also. Nobody really broke it really down for me. You've seen this before. And in fact, let me, bell curve, right?
Yes.
We just calculate the expected time for that project. What you really calculate here is the mean. So that's 23. This tip just went in. Switching. Calling out 23. Now, this line down here is a number line. Numbers get smaller to the left, bigger to the right. 24, 25, 26, 22, 21. But how do you know where to put the numbers? This is what I've always used to use to decide where the numbers go. This tells you that most distributions follow this empirical rule, that 68% of all the possibilities are right here between this area. So this area represents 1 standard deviation above, 1 standard deviation below. And once we know the standard deviation of the project, I want to put my dashes right where the 68% outer is. So I'm going to go like right here. You guys okay with that right there? And then right here. Once we know the standard deviation, this number is going to be 24 point something, because we're going to add 1 standard deviation of it. And then 2 standard deviations. Right here, about right there. And then 3 is about right out here, correct? And we get the 2 over here. Right here, right here. This will, instead of being 23, 24, 25, 26, this is going to be 23, 24 point something, 25 point something, or 26 point something, by adding a standard deviation to each of those. So, how do we find the project standard deviation? You ready? Whoop, whoop. We do a forward and backwards pass. Hang on, we're getting there. And we find the critical path. Which activities were critical? Did we have the right critical path even though we made an error on that one?
Yeah.
We did? So I stays the critical path then? So our critical path ended up being A, C, F, I, K. I'm going to save you a lot of time. Previous semesters, or every semester, somebody sitting right now who can hear my voice just as well as you can hear your voice, and my voice, excuse me, is going to figure out the variance for every one of these activities, and you're going to go, why do I not have time to finish this step? You only find the variances of the critical path. Save yourself time. Everybody hear that? You only want to find the variances of the critical path. Do not convert those variances until you've got them all added together. Let me say that again. You find the variances of only the critical path and you add them together. Now, the formula for finding the variance is about 2 slides, 3 slides back, or 4 slides back. So we're going to try one. I want to make sure you get it. Going back to right here. Same activity. We'll do H. It says you take the longest amount of time, which is the pessimistic time, subtract the smallest amount of time, which is the optimistic time. So in this H, we had what? Here it is. This is what you should have written down, actually. If you have followed this exact thing, this will always lead you to Z, which will always give you the probability of the asked about time or less. Let me put this, let me highlight that. If you follow that, and then it always will give you the Z that you will then look up, and it will always be the probability for whatever amount of time being asked about or less. This is, and if you accidentally turn these, and then you go look this up, you aren't looking up or less, you're accidentally looking up or more. Instead, stick to this, and everybody should be heading to the right answer. The only catch is, once you find this probability on that chart, if the question says or more, it's the opposite of this. So if this is 40%, the or more would be 60%. If this is 30%, the or more would be 70%. 100% minus whatever this turns out to be if the question says or more. It's either going to say or less or more. Got it? So, are you ready? The critical path we know, and we're going to calculate the variance for H, which is the longest amount of time is a 7, minus the shortest amount of time, which is 5, right? And then we take that, divide by 6. So what do we got? What's 2 divided by 6? 2 divided by 6, what is that, 1/3? Then, square it. 1/3, where's my calculator? No, you don't, not to do it. Hey, Henry, Shannon, you're my calculator. What's going on? They don't even need to take those. They don't even need to. You ready? Here we go. What was 1/3? 0.33 squared. What'd you get? 0.1111. Oh, that's it? 0.1. There's the variance. Then you do that for each one of the critical activities. So you're going to have, how many critical activities do you have? 5? Right there. 1, 2, 3, 4, 5. We're going to get 5 of these, and then we're going to add them together. Go ahead.
Why did we square it? Once we found 1/3, why did we square it?
Well, actually, you really are calculating the standard deviation. You're squaring it to turn it back into a variance. And let me show you. Right here. You take the longest amount of time minus the smallest amount of time, then divide by 6 and square it. We're divided by 6 because we're using 6 numbers. We're using 6 digits to get all of our weighted averages, and then we're squaring it to turn it into a variance. You've got to square these and add them together before you square root. And I'm almost sure you won't get the right answer if you're adding the standard deviations. You've got to add them all as variances first, then square root. Don't square root each one, then add. Even though mathematically it seems like it would work. I mean, tough on the word. So, you ready? Right here. Except they're in, instead of being in decimals, they're in fractions. What was H? 1/9, 1/3 squared, 0.111. What's another one here? Another critical activity is A1, right? 4/9, which is that'd be point something. 0.44444. So we take those 5 activities that are critical, we find the variance, we add the variances together. Are you ready? The critical path, ACFIK. The expected time, 23 units of time. There's our center. By the way, what % chance that this project will get done in 23 units of time or less? 50%. What's the probability this project will take 23 units of time or more? 50%. That's what you calculate with uncertain activity times. When you change all the times, do your forward pass, you're calculating the mean, which is 50%, 50%. Now, if you remember, I talked about a bridge loan. If I go to the bank and I say, hey, I want this $3 million, $4 million, whatever amount of money on a bridge loan, and you have conversations about what it's for. You got to show them financials. You got to show them the architectural structure. You got to show them the plan, the activity schedule, everything to get this bridge loan. And if I said to them, yeah, we're going to be done in 23 days, and they're going, wait a minute. You know, they see that this is an uncertain activity time project. They're going to say, you only have a 50% chance of getting done in 23 units of time. You know, we don't want to lend on you only having a 50% chance of getting done, because they've experienced this. Every bank who's done commercial loans know that this project you're working on is that you as a borrower are depending on the revenue that's going to be coming from that project to start paying the principal on that loan. That's the whole point. And if that project isn't done, by the time you got to start paying that principal, your cash will start going out the window fast, because you are not budgeting to use your cash to pay the principal. You're budgeting for the revenue of that project to pay the principal. That's the whole point. So what you need to do is figure out what amount of time will get you to a higher % chance that this project will be done in that amount of time or less. So we need to know what this is out here. If this is a number line, what number would be out here giving us like an 80 or 90 or even a 95% chance it's going to be finished? And the bank's saying, let's plan that schedule. Because with 95% chance or a 90% chance it's going to be done, we can all sleep well knowing that you're not going to have to start making payments out of your reserve cash instead of the revenue, because it didn't get finished in time. I can remember, by the way, I just remembered something that happened once. We were building a dorm, and we all feared the way we ended up having slowdowns after slowdowns because of subcontractors not showing up when they're supposed to be showing up, delaying the whole project. That we got to a point to where we truly feared that this was not going to be ready for students to move in September. And this was a big deal. We have already accepted deposits for all of these dorm rooms for these students to move in. So we were getting frantic, and it's a long story. This is exactly what happens. These are the kind of things you got to plan for. I always say, plan for the worst and hope for the best. That's in life. That's how it is in business. Plan for the worst, hope for the best, but always be prepared. Are you ready? So we're adding up the variances of those 5 activities. Here they are. 4/9, which is 0.444. 0 is the other one. 1/9, which is 0.111. We got a 1 here, big variance. 0.444. You add these up. The project variance is 2 units of time, square rooted. The project standard deviation is 1.414. That's the number we needed. That's the number that will now tell us what this dash is right here on this number line. 23 plus 1 standard deviation, what does that make this? 24.414, we'll just call it 4. Now, I need a calculator here. 24.4 plus another 1.41, oh, that's easy. That's going to be 25.8, does that sound right? We're good? Now, let's subtract 1.4. So we're at 21.6. Help me out. Is that right? Now we're subtracting another 1.4, so we're at 20.2. My number line doesn't look normal because I didn't use 22, 21, 20, or 24, 25, 26, but I put these numbers right following the empirical rule, and I know that wherever the number is we're about to measure is going to fall in the right place, and I'm going to know the probability for whatever time or less. And the opposite would be whatever time or more. You ready? Here we go. We're following this rule. The question is, this question says, hey, it's supposed to take 23 units of time. So what's the probability it will get done in 24 units of time or less? Follow this formula. Ready? What we're being asked about. 24 minus, what's the expected time? 23 divided by 1.414, this project standard deviation. You end up getting 0.71. Anybody has a book, go to Appendix A in the back. What? I don't hear any movement. Appendix A. And almost there. Here we go. I want to give you a heads up. You definitely need this for the quiz. You need this. If you don't have this in the back of your book, print something off the internet. They're all the exact same tables. They're always showing you the probability to the left, which means any one of these spots or less. The question says, what's the probability it will take 24 units of time or less when it's expected to take 23? Standard deviation of 1.414. We got a 0.71. We're on the negative. Let's get to the positive, which makes sense because the number we're being asked about is larger than the expected time. Go to 0.71. Here's 0.7. The next digit would be a 1, so you go over to the 1, 0.71. The probability that this project will be done in 24 units of time, when it's expected to take 23, is 76% chance. Where's 24? About right here? Is that, you guys call that 24 maybe? So this is a 76% chance. I already forgot. Is it? Yeah. 76% chance. What's the percent chance? Is this probably, okay, bank, we set it all up. I'm going to start paying principal now with interest on unit of time 24, whether it's day, week, hours, 24, won't be hours. And they're saying, okay, you have what percent chance that you're not going to have this project done, and you won't, and you're going to have to use your own reserve to start paying on principal. What percent chance of that? That it's going to take longer than 24 units of time. Not all at once, we are recording. Couldn't hear you. What's the opposite of 76? 24% chance. What we just calculated is the percent chance it will take an amount of time, which in this case is 24 or less. The opposite, it will take longer, and it won't be done in time. The opposite is 76%. Let's do. I want to make sure you get this. I can tell by a lot of hesitations. We got to look at another one. You ready? It's supposed to take 23 units of time. The project standard deviation is 1.414, I think. And the question says, what's the chance you can get it done early? Let's say you get this done in 21 units of time or less. Follow this rule. 21 minus 23 divided by 1.414, hit me with a Z, equals 1.75? Negative 1.75. When we look up negative 1.75, that's going to tell us the probability is going to take that amount of time or less. The question said, what's the probability you're going to get this done early, which means that amount of time or less, but I'll be more specific on test. I'm not going to leave you hanging. It will say, what's the probability it will take 21 units of time or less? You got to go to the negative. 1.75, is that what it is? Negative 1.7 is right here. Go to the 5. Is that it? No. 0.04. There's only, what was the number here? 21? Where's 21? About right. Hang on, man. I'm going to say 21 maybe about right there. And this was a 4. What did I do wrong? Am I lost? We okay? Charlie, you got me?
I think it is 1.410.
Okay, hang on. Oh, that's impossible though. 21 minus 23 is 2. 2 divided by 1.414. What's 2 to, oh, maybe she's right.
It's negative 1.4.
Where'd you get 1.75? Who hit me with this, Hunter? Man, you're fired. 1.414, thank you, Charlie. 1.414, we're looking this up again. 1.4, 1. Where's the 2? What's the next digit? 4? We'll go with the 1. So 0.0793, ready? 7.93% is the percent chance that we're going to get this done early. What's the percent chance that we were not going to get it done early, that we're not going to get it done in 21 units of time or less? 92. That's right. The opposite of that, but a little over 92% chance. Everybody getting this? You want to do one more? One more? I hear yes. Okay. Let me think of an odd one here. What's the probability that we're going to get this done, that we're going to take longer than 25 units of time? You ever hear that? What's the probability that this is going to take longer than 25 units of time? Because I just negotiated with the bank that 25 units of time will be the date in which we start making payments on the principal. That we're going to be handing them some real cash. We're talking take about $1 million divided by 12, so we're spending over $100,000 a month now on this loan. And What'd I say, 25? Take longer than 25, is that what I said? Help me out, 25 minus 23, what a coincidence. It's gonna be a positive 1.414, because this is 2 divided by 1.414 again, right? Charlie, help me out, is that
Yeah,
true?
that's right.
Thank you. Hunter, did you want to add to this? Okay, making sure. Positive 1.414, so I go here. We go to 1.414, so it'd be right here. A little over 92% chance that it will take 25 units of time or less. But the question wasn't about 25 units of time or less, right? It said, what's the probability that we're going to be, we just negotiated 25 units of time, and what's the probability that we're going to end up taking longer than that and not being able to make that payment out of revenue, instead we'll take it out of our cash reserve on that. So be the opposite, which is 8%, or a little less than 8%. It's this one, 7.93%, because it's the opposite side. Everybody see that? You can do the more than, less than. This is stats. It's really easy now, right? Everybody get it? Can you find the standard deviation of a project? I want to give you a hint. Sometimes you may already be given the variances for every activity like this. You can see it. You know, it's possible you may be given a problem where the variances are given to you. And if it says, find the project standard deviation, everybody hear this? You got to realize only grab the numbers you need that are on the critical path, then add them together. But that's square rooted, and that would be the project standard deviation. Don't use all these. Only the ones that are on the critical path, and then you add them together. And you got the project variance. Square rooted, now you got the project standard deviation. You'll be given the expected time. So you can now calculate the probability of any amount of time around that expected time, because you'll have the standard deviation for the project. You'll have the expected time, and questions can start. That's all you need. We feel okay. Let's keep going. Boom. The last part of this chapter is crashing. Crashing, crashing, crashing. All right, where do I want to put this? Can I erase anything? Can I erase this over here? Everybody okay with this? Here we go. Now, my hint on crashing is that I always start by forming two columns and do some calculations right off the bat. This will make sense in a minute. Because all crashing problems look like this. And I start right off the bat by finding the difference from regular cost to crashing cost, and finding the difference in what is the amount of time we'll save if we spend that extra money. Now this is real. You get this project, you're in charge, and you have all these meetings, and you come up with all these times for every activity for this project, right? Longest amount of time. You've gotten such debates during these meetings that you've broken a few good relationships because people are debating, no, there's no way, da-da-da. And that's how it is sometimes. It's awful. But you're the project leader, so you got to put it together. And then, all of a sudden, you come up with the expected time, you got your variance, your project standard deviation, the probabilities, and someone says, we need this to be done sooner. We need, and money doesn't matter, we just need it done before that expected time. And so that's called crashing a project. And it always costs money. At that point in time, everybody who's involved in all the activities and these activity times and these costs got to get on the phone with everybody that was involved in coming up with these numbers. And usually this is like subcontractors, but you have people in your office that help gather this information. And whoever was in charge of this activity, they got to get on the phone. They got to call them up and say, look, can this get done any faster? If you have additional help, could you get this activity done faster? Yeah, we can get it done in one less day or one less week, whatever this time is. But it's going to cost an extra $20,000. Okay, thank you. I'll get back to you. We're still working this out. Activity B, same thing. Someone else called them. Hey, you said it would take 4, whatever this time is, weeks maybe. It's going to cost $100,000. If it needed to be done sooner, is there any way it could be done faster? Yeah, no. Not that. This one's no. That's it. There's your cost. That's the time. There's no way to get it done faster. Okay, go to the next one. Same thing. 3, 50,000. We can get it done faster, but it's twice the price. That's all we need to know. And you get this for every one of these. This is the work. Now, once you have this, to be able to solve this is all about, and you gotta remember, right now if I said to you, which activity should be crashed, you guys are gonna start staring at this. And by the way, let's say we need to cut 2 units at a time. You should be jumping to whatever the least expensive one to crash is, right? You go, well, maybe we can take one off here because that's not too expensive. And maybe we take one off there. But what you're looking at is just a simple, what is that, 10, 12 activities. You can't just look at it and say which activities you're going to cut back on when you have so many activities involved. Instead, you got to write a linear programming problem. And this linear programming problem, if you follow the simple steps I'm going to tell you, these little like rules, it turns this into a very simple process. Okay, it turns this, George?
Did you say that you got to jump to the least expensive activity to crash?
You got to find the least. You want to crash the activity, meaning taking some time off it,
Yeah.
and spend the least amount of money you have to get it down in time.
Okay. Then
So, for example, go ahead. Which activity are you about to point out?
no, I was asking, and then then why do we need a linear programming if I can just see which one is cheaper?
Because right now you can look at it because it's such a small amount of activities. In real life, you have 100 or 1,000 activities.
Okay.
You would have to be staring at pages and pages and pages trying to figure out which one's the cheapest.
All right, makes sense.
All right, so which activities would you choose? Let's see if you're, well, you're looking at the PowerPoint. You know which activity. Go ahead, which activity would you choose?
Oh, I was.
Well, you encourage her to say A? A? Okay, let's go. A is only 20,000. So without using any math, we'll say A, but that'll only get us 1. We got to cut another one. What's the second one you're going to cut? C? Okay, we'll go with C with the other one. A and C. You know what? I think there's a chance we got to cut 3. I. You're looking at the PowerPoint.
No.
Are you swearing?
What about E?
Huh? You want B?
No, E.
E. Okay, so let's stop there. We got A, I forgot what this is, C, I, and E. Let's see if they're correct on those of the activities, because what I'm about to teach you will tell you exactly which activities should be used to reduce time. And that's what crashing is. In this example, this company, where are we? This company says they want to do a new product. It's a new line of loaders. And this is exactly when project scheduling is done the most, is when a company wants to get into a new line. This is very typical. The manager's concerned that the project may take 26 weeks to complete to get this new loader line project all set up. And they want it done faster. They're afraid it might take too long. So they said, here's all the activities. Here's the activities that immediately precede each of them. Here is the completion time. And what's great about this one's known completion times. We don't have to convert the times at this point, right? We do our forward pass, our backwards pass, to find out the expected project time after we spent, I can't tell you how long we spent to put this together with all the meetings we went through, weeks. And we got this now, we do our forward pass and backwards pass, and we get this. This is just the numbers, wait, we see, there we go. We get this, how much time to complete this new loader project? 30 units of time. So what's happening is, whichever ones go to the finish, here's the earliest finish, they both have to be done, so 30. There's the expected amount of time. The company said, we need this to only take 26 weeks, a half a year. We got to cut not just 3, but 4 units of time. 4 weeks have to be cut out of it. Everybody gets on the phone. Hey, I know you said this is going to take this long, we want to cut some time, how much can we cut, how much will it cost? No problem. We get back to our meeting. By the way, this takes another whole week. Everybody gets back together. Here's what we can do. Here's our options. Here's our costs. All right, let's write this in a linear programming model to select the exact right activities. This will spend the least amount of money to get this down to 26. And the first thing I like to do is to find the difference in the amount of times. All right, if I had all these here, A, B, C, blah, blah, blah. How much time could be saved with activity A if we were to use it? The most amount of time we could use it for? 1 unit time. What about B? 0. What about C? Is it only 1? Yes. Okay, I see now. What about D? 3. Very good. E? F, 3, and G, 0, H, 1, and I, 4. Okay, next. How much money is it going to cost us for each activity if we take full advantage of it and make that the full crashing as to whatever's available there? In A, how much extra money would be spent? 20,000. I'm going to write everything like as if there's a K there, okay? All right. B, 0. C, 50. Wow. Did somebody say C? 50,000? Who is that? No, you don't want to. D,
150.
150. Oh my God. E,
70.
is it? Come on, you guys. I'm only here. F,
180.
180. Okay. G,
0.
I,
350.
350,000.
Yes.
Wow. The I,
300.
300. Okay, let me look at H. Did anybody say H? I would have really given you H. All right, now, last step. We have to take the total money, the total amount of money it costs, divided by the total number of units of time we would save, because this is what we have to have, is cost per unit of time. The cost for 1 unit of time. 20,000 divided by 1 is 20,000. 0 divided by 0 is 0. 50,000 divided by 1 is 50,000. 150,000 divided by 3, 50,000. 70,000 divided by 1, 180,000 divided by 3.
60.
Thank you. 0 divided by 0, 350 divided by 1. That's out of it. No, I'm sorry, we got to use it. 300 divided by 4.
75.
Is that 75? Now, here's what's happening. In crashing, you have to have a variable for every activity called an X variable, just like we've used before. How many X variables do you see? Because there's 9 activities. So we have X sub A, X sub B, X sub C, right? All the way down. And then you need a Y variable for every activity. So we have how many more variables? 9. Y sub A, Y sub B. Everybody get it? The X variables and the Y variables. The Y variables are the amount of the activity that will be crashed. Y represents how much it can be crashed. So, are you ready now? We have all these numbers right here, and we're going to turn it into an objective function and a constraint. We're going to start with the objective function. The objective function is always to minimize, and it uses every Y variable for every activity unless it's not going to be minimized at all because it's a 0, our crash. B is a 0 and G is a 0, so there's no reason to put a 0 up here, so they shouldn't even be up here. Y sub A times the amount it will cost per 1 unit of time of crashing. So that this column, there should be a 20, a 50 with C. Is that true? A 50 with D, a 70 with E. 20, 50, 50, 70. These are in thousands. 60, 350, 75. With the variable Y, sub whatever activity represents. You did this work right here to write your objective function. Get it? All right. Next, you did this work right here to write your Y constraints, they're called. These are the Y constraints. It's the Y with each activity variable less than equal to the number of units it could be crashed. Y sub A less than equal to 1 because there's only 1 unit available. B's gone because it won't be crashed. It's a 0. Y sub C less than equal to 1. There's only 1. D, there should be a 3. Y sub D less than equal to 3. All the way exactly to the numbers you have in this column when I asked you how many units could be crashed. So that's easy, right? Objective function's easy. Y constraints are easy. Correct? Go ahead, Chuck.
So this only works if it's proportionate per unit of time that you're crashing.
What do you mean by proportion to unit time?
So, for example, right, you have 100 D, right? You have $150,000 that they want for crashing in 3 days, right?
3 units of time, whatever it is.
Time, yeah, 3 units of time, right? So what if they have an increasing amount, so depending on how much you want to crash?
Oh, yeah, you're right.
value
Yeah, yeah, yeah.
increases.
You see what he's saying there? He's saying if you only crash at 1, maybe it's only going to cost you 50 or 40, So if you're crashing 2, they need 60, a different amount for each one. You almost got to treat it like it's a separate activity in a way. In most cases, I have not experienced that, but I know it could happen. But I have not experienced it. In my experience, it's always been a flat amount that we would then divide by the number and get a regular amount. But I see your point. You wouldn't be able to do it this way. Even though I have not experienced that happen with any subcontractors I've done. Now, here's the harder ones right here. But they're all done following this logical process I'm about to tell you. On the left is the X variable for whatever activity you're writing the constraint for. And these are called the X constraints. Here's the Y constraints, here's the X constraints, here's your objective function. The X constraint starts with the X variable for whatever activity you're writing this for, and we're starting with A. These X constraints for an activity are always greater than equal, not less than, greater than equal. The next is the X variable for whatever activity precedes it. But in A's case, there is no activity preceding it. Just look at our drawing. See A? No activity precedes it, so instead of putting the X variable there, we had to put 0. So let me repeat this. On the left is the X variable for whatever activity you're writing this for, greater than or equal to the X variable for whatever activity precedes it, in this case is 0 because it has nothing preceding it, plus, parentheses, the normal, usual, expected time of that activity, not the crashing time, the regular time. So look at A at the 2 different times we have up here. This is normal time. This is the time if we were to crash it by 1 unit. This is the number you use for all of these, for these X constraints. These are the numbers you use, normal time. The X variable for the preceding activity plus, parentheses, the normal time for the activity you're writing this for, minus the Y variable for the activity you're writing this for. So this A and that A should always match. B, B, C, C. Get it? I want to repeat it one time. I'm going to go now to the B one so you can see it a little different. The left-hand side is the X. Go ahead, Doc.
Is that always a letter instead of a number, though?
These,
Yes.
when you're setting it up, it's all letters, yes, except for the normal time.
Okay.
And this is the only reason that's the numbers because it wasn't preceded by anything.
Yep.
Yep, just the exact same process. So this is, we're going to write an X constraint for activity B. The X variable for activity B, greater than or equal to the X variable for whatever activity precedes it. Well, we better go look at B. Sure enough, what precedes B? A. So we got to put X sub A there. Don't worry, this is going to get a little more difficult here when we get to one that has more than one preceding. X sub B, we're writing this for B, greater than or equal to the preceding activity's X variable, X sub A, plus, parentheses, the normal time for the variable or for the activity you're writing this for, which is 4, minus the Y variable for the activity you're writing this for, which is B. So you can set these up, right? I want to make sure you can set them up. Once you get these out, you don't look at these on your PowerPoint. Don't look down. Hang on. Let's write. Let me go up here. Activity H. Activity H. What do I start with? X sub H. Thank you. Now what? Greater than or equal to what goes here? X sub what?
G.
That's right. Whatever the X variable for whatever precedes it. Now what's next? Plus, parenthesis, 6. Now she's looking at the box right underneath the G, or underneath the H is a 6, or we could look right here. Is H a 6? Yes, so let's go back. So we're writing 6 minus what? Y sub H. You've just set up the X constraint for activity H. All right, let's do G. What are you noticing about G? There's 2 activities that precede it. Here's the deal. You do it exactly like we learned. X sub G greater than or equal to, pick one. This one? X sub E plus, are we doing G? 2 minus Y sub G. Now you gotta do it again, using this as the x sub f now. So there'll be two x constraints for that activity. There'll be two x constraints for that activity. One that has B, one that has C. Those are the only two? There'll be two x constraints for this activity. One that has D, one that has G. Let me show you. Anytime an activity has more than one activity preceding it, you repeat the whole process up to that little change. Which one had two? Where's H? No, H didn't have two. G did. F, thank you. F. X sub f greater than or equal to x sub b plus the normal time for f10 minus y sub f. It has another activity. There's x sub f again, and everything's the exact same except the other activity that precedes it, which is c. So you got x sub b in one, x sub c in the other. We have two of them because there were two activities preceding f. And so that determines how many x variables you have based on how many other activities preceded. So there should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 x constraints, right? And sure enough, because we counted 2 for those that have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This one. Now, what are these? These are special constraints. Anytime you're crashing a project, you got to say to yourself, which activities do not precede any other activities, that they go straight to the finish. In this case, we had two activities going straight to the finish. At I and H, you have to take the x variables for any activities that do not precede any other activities, and they go straight to the finish, and you're going to make them less than, let me repeat that, not greater than, less than equal to whatever amount of time you're trying to crash this project to. Now, this is supposed to take 30 weeks, I think. We're trying to get it down to 26. So we're going to make sure x sub h is less than equal to 26, x sub I is less than equal to 26. These are those last two constraints right here. X sub h, x sub I, because they go to the finish. That's how you set this up. That's it. It's almost too easy now. One last thing. You have, in real life, you got to apply algebra to every one of these x constraints because you can't have variables on the right side. You got to get them to the left. I want to do a couple algebra, apply a couple algebra because I know that your quiz or your homework, you're going to have to apply some algebra to these after you set these up. So let's just pick C. Oh no, we got one right here. X sub h greater than or equal to x sub g plus 6 minus y sub h. I'm going to get rid of the parentheses. I'm leaving the 6 over there, but I'm adding y sub h to both sides, and I'm subtracting x sub g on both sides. So what do I have left? This cancels out, leaving just a 6 over here. I have x sub h minus, here we go, x sub h minus x sub g, and was this added or subtraction? Plus y sub h, now all the variables are on the left, greater than or equal to 6. All I left on the right, and now I can enter it into Excel or the software to be solved. 1 underneath this variable, -1 underneath this variable, +1 underneath this variable, and a 6 on the right hand side, and a greater than. And when you do this, hang on, it looks like this. Here's all my x variables in the objective function. Why are there no numbers underneath it? Look, hang on. Because the objective function doesn't use any of the x variables, only the y variables. So let me go back. Look at the y. Y sub a has a 20. Man, how do I smooth this over? There we go. Y sub c is a 50. Y sub d is a 50. E, F, G, H, I. Now down here, these are all the constraints. Let's see if I can get down there. Come on. Let me get to the right side. These are all those constraints. Here's all your y constraints. Y sub I less than or equal to 4. Y sub f less than or equal to 3. There's the y constraints. Here's your x constraints for the activities. Your 1s and -1s will be across there after you apply the algebra. And then these two Those are those last two activities that go to the end that have to be set to less than or equal to whatever it is you're crashing to. Uh-oh. Anybody hear that? Time for our in class. We're going to run out of time. You ready? Here we go. My question for you is, you should remember what I said the variables represent, is which activities are going to be crashed and by how many units of time? Name one activity is going to be crashed by analyzing that output.
Just name one.
Name one. According to the output though, what do you see on that output is going to tell you which activity is being crashed? What? A and F. Let me look. That is correct. A and F. What? Don't tell me why. Why? How did he know it was A and F? What do you see? Come on, what did you see? What do you see on A and F? What made you decide what made him decide that's the activity being crashed? Huh?
Zero.
No, not the zero. One. Because the Y variables represent the crash. You go straight to the Y variables and look at their values. All the Y variables have zeros except for two of them, A and F. And how much is A being crashed? We gotta get 4 units of timeout. How much is A being crashed? 1 unit. How much is F being crashed? There it is. There's how you know, and there is no less expensive crashing cost, no matter what combination that might exist. The least amount of money we gotta spend to get this 4 units of time out of this freaking project is how much money? $200,000. That's your expected, your objective function value, and that's the least we're gonna have to spend to get it down to 26 weeks. This saves you a ton of time. You know exactly which activities. You get a hold of those 2 activities. You say, you're on. We need 1 unit timeout. We're willing to spend the extra money out of that $200,000, which, by the way, is, and F, you're on for 3 units of time at whatever that cost is. Where's that cost? 180,000, 60, 60, and 60. And what was the other one? 8? 20,000. Whoever said A is correct. Did anybody else say F? Now, one of you thought it was F. So this is why, even with a little amount of activities, 12 or 9 or whatever, linear programming will get you to the best answer and spend the least amount of money. You ready? Usual situation on in class. Everybody feel okay with crashing? Because I know this is on your homework that I'm posting tonight due Tuesday. Now this is going to look hard at first when you read it, and when you realize you're reading too much into it, you're going to realize just how easy this is. Are you ready? Okay, I'll wait. Don't read too much into it. Here we go. I'm going to read it out loud. Calculate the probability that this project will be completed in 21 units of time or less based on the following information. The expected completion time equals 22.17 units of time. The critical path is CFG. Show your work, show your calculations and everything to find the probability it will take 21 units of time or less, when usually it's going to take 22.17 units of time is the expected time. That, if I have my bell curve here, the center is 22.17. Anyone panicking?
Yeah.
You got John. What? He's panicking too? Well, who said they got Austin? Good for you.
All right, good. Let me
That's it. I'm happy about it.